a few integration problems. Can you just confirm quickly for me that you can see my screen? A thumbs up or anything would be fine.
Yes.
Okay, so looking at the first question here, we have the integral of dx over x root ln x, right? So in your opinion, what method can we use to solve this problem?
Use substitution.
Use substitution. Any other suggestions? Because the way you know is, are you able to solve it easily without doing any substitution? If you can't, then that's sort of an indication that use substitution might be helpful here. So let's try use substitution and let's see where it gets us. What would you want to substitute u with? Any suggestions?
Ln x.
Ln x. Okay, so let's try ln x. Let's see where it gets us. So if you let u be equal to ln x, right? Then you have to find what's the value of du, right? Which is just equal to what? What's the derivative of ln x? I'm asking you guys.
It's 1 over x.
Thank you. So 1 over x dx, right? So then, knowing that, you can go and find what dx is. So dx then is equal to x du, right? When you take the x to the left-hand side. So now you have a relationship between du and dx. Now you take that back to the original question, right? And what do you get? Using u substitution, you get that this is equal to, oh, sorry. This is equal to, remember dx is just x du, so replace that with x du. Ln x is u, so you have u there. And obviously the x can cancel, right? Because it's common in the numerator and the denominator. So when it cancels, you're left with the integral of du.
Then you can't see what you're on the screen.
You can't see my screen. Okay, let me try to share it again. Okay, so let me try to share my screen once more. Yeah, hopefully you can see that. Can you see now?
Yes.
Okay, so then you're left with the du, the integral of du over root u. So, which obviously can be rewritten as, let me just rewrite this, can be rewritten as the integral of u to the negative 1 over 2 du. And what is that integral equal to?
U to the power of half divided by 1 over 2.
Does everyone agree here? Let me just write it down and see if everyone agrees. Over 2. Is this correct?
Plus C.
Okay. I was just about to say C is important because it's a constant of integration. But now, is the actual integration part correct? This part. Does everyone agree with it? Okay, I'll assume that by acquire you agree. So I see a hand risen. You can unmute yourself and ask your question. Okay, so then you can simplify the u to the 1 over 2 to just be equal to the square root of u and divided by 1 over 2, which is just 2, plus c. Right, so you have that. And your original u substitution was u is equal to ln x, so you just plug that back into the equation there. And this is what you get. So with integration problems, the way you know you got the right answer is you should try to derive your answer and see if you get back the original function, 1 over x root ln x. If you do, then you know you did a good integration. So, any questions here? If you don't have one, I will ask you one. Any questions here? Okay. So let me ask you, would there be any other u substitution that could work to solve this integral? For example, could you have used the u substitution? Right? This is just a question that I'm asking you guys to see how you think about this. Could you have used, for example, the u substitution of the square root of Linux? Or even could you have used the u substitution of x? Or could you have used the u substitution of x square root Linux? What do you guys think?
I think you could have used the first one.
The first one. Okay. What about the second one? So,
Yeah,
sorry?
the second one would have also worked.
The second one would have worked. Okay, let's try that. Let's try the second one and let's see what we get. So, if you let u be equal to x, but before we even try it, just think about it. If you let u be equal to x, does it help you change anything here? It just changes the x to u, right? It just becomes du, right? Integral of du over u root ln u. So you basically get the same integral, but now in terms of u instead of in terms of x. So the second one would not work because it just gives you back the same problem. And the whole reason why you're doing U substitution is you're trying to simplify the expression enough so that you can solve the integral. So just give me a minute. Right. So you're using the U substitution in the first place because you wanted to simplify the expression so you can find the integral, which is what happened when we use the substitution here. So we simplified the expression so much that we could then apply simple integration rules to get the answer and then plug back in the initial substitution. So the second one would not work. But what about, I'm intrigued about the third one. Would the third one work? Because we can sort of see how the first one, this first one here would work. But the problem with these U substitutions, especially the first and the third one here, is maybe it might work, right? But the problem is that you might end up taking a longer time to get to the answer than with other substitutions. And the only way you know how to which substitution you should use is by practice. That's the only way you could learn this because there's no set way to do it, at least none that I know of, right? So you sort of have to practice and do it multiple times up to a certain point when they give you any specific problem, then you know, huh, this use substitution might be a little bit faster than the other one. But usually you would have to work it out and see which one takes more steps. Because in an exam or a test setting, you would want to find the fastest solution to solve your problem because you have like 10 questions and you don't have time to spend 30 minutes on one specific question. So it's very important to find the quickest way to solve your problem. Right. So any questions on that? So what I would suggest is try using this substitution and this one as well and see how long it takes you to solve the problem. If it takes you way longer than this, what we did for the first use substitution, then you know you can't use that method in a test or an exam because it takes you way, way too long. So any questions there? Okay. Then moving on, we have the integral of the square root of 1 plus x to the minus 2 over 3, right? So now in this case, is there a U substitution that you guys see can work? Yeah. Hello, anyone? Is there a U substitution that you guys... Sorry?
Yeah.
Yes.
Which
I
one?
tried something. Could you have let u equal to x to the power of negative 1 over 3?
Okay. Let's think about that. Let me just write it down and then just talk about it. So if you let u be equal to x to the power negative 2 over 3.
1 over 3.
Oh,
Yeah.
sorry. You said 2 over 3 or 1 over 3?
1 over 3.
Oh, 1 over 3. Okay. That's so then x to the 2 over 3 would be what? It would be u squared, right? Because if you have u, let me just write it down. If you have u is equal to x to the negative 1 over 3, then u squared would give you u to the negative 2 over 3, which is what you have in the question, right? Negative, oh, yeah. So if you have that, then when you solve for du, du will just be the derivative of x to the negative 1 over 3, which is the negative 1 over 3 comes down, right? Multiplied by x to the negative 1 over 3 minus 1. And this is equal to negative 1 over 3 times x to the power negative 4 over 3 dx, right? So then you would find the expression for dx, which will give you dx is therefore equal to just negative 3 du divided by x to the negative 4 over 3, which is just multiplied by x to the negative 4, sorry, over 3. Right?
You
So
can change the x to the negative 4 over the
sorry,
3. You can change
sorry.
the x. You can change the x there by the dx is equal to minus 3 du. You can change the x to u to the power of 4.
X to the, sorry, can you repeat?
Yes, that x, you can change it to u to the power of 4.
Yes, you can. You can if you want.
Yes.
Yeah, then this would be negative 3 du multiplied by, since you substituted u is equal to x to the negative 1, when you raised u to the power 4, you would have x to the negative 4 over 3. So this would then become u to the 4. Right? So then you have that. Taking it back to the original question, what do you get? So you let your u be equal to x to the negative 1 over 3, meaning this is equal to u squared. And then this dx is equal to negative 3 du times u to the 4. Right? So simplifying this, what you get is the integral. I'll take the negative 3 out because it's a constant. Negative 3 multiplied by the integral of u to the 4 multiplied by the square root of u squared. So then what do you do from here? Oh, du. What do you do from here?
Jonathan, you're supposed to divide by that u over 4, u to the power of 4.
Sorry, u to the power 4. No,
From the previous
because
section.
here. Oh, here.
Yeah,
You mean it's
previous
u to
section,
the
previous
4.
section.
Sorry,
It's u
go
to the
ahead.
4. It's negative 3 du divided by u to the 4.
Oh, okay. So it would be u to the 4. So this is 1 over, 1 over u to the 4, which is then 1 over u to the 4 here, and 1 over u to the 4 there. Okay. Then what?
And then it's still there. Yeah.
Sorry?
Okay, then apply use substitution again, but you
So
need to say k squared is equal
so
to
you used use substitution again.
1 plus v to the
So that's what I was mentioning when I said you should pay attention to what method you use to solve these problems. So as you can see, this goes on again to another u substitution. So basically you're using a double substitution. So, and then you can't use u anymore because so you do it like an a substitution, right? Meaning instead of u, you just use a, so you don't confuse your letters. And this goes on, right? So you keep going. But as you can see, this question is supposed to take you like maybe 5 to 10 minutes max. But at this point, you just keep on going and going. It might take you a very long time, right? So what I would suggest is before you even do this integration, you simplify the expression. So what do I mean by simplify the expression? I'll just leave that down there. Well, we have the integral of the square root of 1 plus x to the negative 2 over 3, right? Which you can write as, just rewrite as the square root of x to the 2 over 3 multiplied by 1 plus x to the negative 2 over 3 all divided by x to the 2 over 3. Oh, sorry, just not sure why it's doing that. Oh, let me just. So this is what you have. You guys agree that these two equations are equivalent, right? You just multiply.
The screen is frozen.
Sorry? Let me reshare my screen again then.
Never mind, sorry, it was my network.
Okay, so then can you agree that these two expressions are equivalent?
Yeah. Yes.
Oh, okay. So then, since these two are equivalent, when you multiply in the x to the 2 over 3 into the brackets, what you get is x to the 2 over 3 plus x to the 2 over 3 times x to the negative 2 over 3 is just x to the 0, which is 1. So 1, right? And this is all divided by x to the 2 over 3. And now that you have that,
So how did you get 1 when you multiplied x raised by 2 over 3 with x raised by negative 2 over 3?
sorry, how did I get?
How did you get the 1 when you multiplied x raised by 2 over 3 multiplied by x raised by negative 2 over 3?
Let me write it out there. Let me write it here. So x to the negative 2 over 3 multiplied by x to the 2 over 3 is equal to x to the negative 2 over 3 plus 3 plus 2 over 3 is just 0, right? So it's x to the 0, which is equal to 1. Does that make sense now?
Yes, thank you.
Yeah, so that's what it's equal. So then when you simplify this expression here, you have in the numerator 1 over x to the sorry, my mistake. Let me just rewrite this. So you have in the numerator, you can break up the square root into the numerator and the denominator, right? So you can have x to the 2 over 3 plus 1 in the numerator, that divided by the square root of x to the 2 over 3. Does this make sense to you guys?
Yes.
Then this can be equal to, so this can be equal to the square root of x to the 2 over 3 is just equal to x to the 1 over 3. Right? I hope you guys can see that. So then this is what you have as your simplified integral. And now you can use substitution to solve this. And can you guys suggest what u substitution we can use maybe?
Is equal to x to the power of 1 over 3.
X to the power 1 over 3.
I think
Okay.
we should let x to
No,
the power 2 over 3 equals u.
Right. So let's try that. I would even suggest to get rid of the 1 there, we let 1 plus x to the 2 over 3 be equal to u. So then we get rid of this entire thing under the square root, because the issue with leaving the 1 there is then you would have something like the integral of the square root of u plus 1, right? Which is another integral that might take you some time to solve, divided by something outside, but that's something is not really going to help us to solve the integral that is under the square root sign. So you would want to get rid of the 1 there, so you have the square root of only one value that you can easily solve. So I suggest let u equal to 1 plus x to the 2 over 3, right? So then your du will be equal to the 2 over 3 can come down, multiplied by x to the 2 over 3 minus 1, which is just negative 1 over 3, right? Multiplied by dx. And then the dx will be equal to, if you solve for it, just 3 over 2 du multiplied by x to the power of 1 over 3, right? So that's what you have for dx. So then you can place that back into your original integral. And what you get is, since you let all of this be u, this is just the square root of u, and dx is 3 over 2 multiplied by du multiplied by x to the 1 over 3. And this x to the 1 over 3 can cancel with the other x to the 1 over 3 that is in the denominator, right? So then you have the square root of u, right? Basically, it's the square root of u, the integral of the square root of u multiplied by the 3 over 2 is a constant, so it can come out 3 over 2 multiplied by du. So the integral of root u du, right? Which can easily be solved. So what's that integral equal to?
U to the power of 3 over 2 divided by 3 over 2.
Exactly. So it's u to the power of 3 over 2 divided by 3 over 2 plus c. Don't forget the constant of integration. And that is equal to, the 3 over 2 can cancel, so that is equal to u to the power of 3 over 2 plus c. And remember your initial substitution. You have now 1 plus x to the power of 2 over 3. Oh, don't know why this is uppercase. All to the 3 over 2 plus c. And that's it. Any questions? Yeah. So now, the reason why I suggested this way is you don't have to do 2 u substitutions. As you can see, we only did 1 u substitutions that helped us get to the solution. And the only thing that we had to do before we did the substitution was to simplify the expression, which is what we did here. So if you had used this substitution, after this point, you've already done 1 u substitution. Obviously, you would have to do another u substitution to solve this. Or rather, you can't use u anymore because you've already used u, so you can use c or a or any other letter, really. You would do another substitution using that letter. So and then if you get to a point where you can't easily solve, so you need to bring in another U substitution. That's like 2 or 3 U substitutions in a row. And that takes a lot of time. And also, there's a higher chance of a mistake when you're doing all of those substitutions. At some point along the way, you could make a mistake, and it might mess up your entire solution. So yeah, just pay attention to that. Assuming there's no other questions, I'll move on. For the sake of time, I'll go through this one, which is the one that you guys said a few people said they had trouble with. I'll go through that one, and then if we have a little bit more time, I'll go back to the other ones. But it's basically all U substitution mainly. So in this case, what U substitution would just suggest, and bear in mind all the tricks that we mentioned. You're trying to get rid, the reason why you're using U substitution is you're trying to simplify the expression. So obviously you would want to choose the U substitution that makes your life easier, not harder. So what U substitution can you suggest for this one?
It's U equal to 1 minus x.
That's a good one. So let's try that. U is equal to 1 minus x, right? So then you would have, du is equal to negative dx, right? And therefore, you can take that back into the original expression. So oh, sorry. So taking it back, I'm not sure why it's keeping all of this. Dx. So taking it back into the original expression, we have that is equal to x times root u, and dx is just minus du. So you have minus du there. And x, because you have that u is equal to 1 minus x, it means that x is just equal to what? I'm asking you guys.
1 minus u.
Exactly, 1 minus u.
1
So
minus u.
1 minus u. And then you can simplify this even further. The negative can come out of the integration sign. And under the integral, you have when you multiply in the square root of x, you have square root of u, sorry, not the square root of x, but square root of u, minus u to the 3/2 all multiplied by du, right? I hope this makes sense. And this, of course, you can easily solve by just using your rules of integration. So when you have the integral of the sum or the difference, it doesn't matter, the sum or the difference of multiple functions, you can just take the integral of each of the functions and then add them up or subtract them depending on the operation that you're doing. I see a hand risen. Please ask a question if you have any.
Sir,
Yes.
I'm a bit confused about du equals to negative dx.
Yes. The integral. This is the derivative, sorry. U is equal to 1 minus x. So du, when you take the derivative, is equal to, what's the derivative of 1? The derivative of 1 is 0.
0.
And then minus the derivative of x, which is just 1.
Okay, sir.
Negative 1
Thank
times
you.
dx, yes. So then you can solve this easily by just taking two integrals, basically. Take the integral of square root, you subtract that from the integral of u to the 3 over 2. Don't forget the sign here, and don't forget to plug back in your original substitution, and don't forget the constant of integration. So I'm sure you guys can continue on here. Right, so any questions on this? Okay, moving on. Let's go back to this. Let's take this the trigonometric one because we haven't really looked at any. So looking at this question here and knowing that we will use u substitution, what do you think we can use as a substitution there?
One plus sine
Basically, 1
for
plus
this.
sine 4 theta.
Okay, so that's a good suggestion. Let's try that and see what it gives us. So if you let u is equal to 1 plus sine 4 theta, then you have that du is therefore equal to the derivative of 1 is 0, and the derivative of sine is cos. So you have cos 4 theta, but now multiplied by the derivative of the inside function in terms of theta, which is just 4. So you have 4 there. And this is multiplied by d theta. Right? So then you can express d theta as the function, and you have du divided by 4 cos 4 theta and then you can take this back into the original. You can take this back into the original integral, and you have that 4. Since you have that d is equal to 4 cos 4 theta d theta, you have that this now can be replaced by du over 4. I see a hand risen, but just give me a minute to write this down. And divided by u to the 4. Remember your substitution. And this can be simplified to be du divided by 4u squared, u to the 4. And obviously, since 1/4 is a constant, you can take it out of the integral. And you have this that is left. And this is an easy integral that you guys can solve. So find out what's the integral there and let me know. Was there a question? I saw a hand risen.
Sir,
Yes.
where does the 4 from du is equal to 4 cos 4 theta come from? The first 4.
Which one?
4.
Here.
Yes.
It's the derivative of du. So you have u is equal to 1 plus sine 4 theta. When you take the derivative of u now, you have the derivative of 1 is 0 plus the derivative of sine 4 theta, which is just 4 cos 4 theta multiplied by d theta. Does that make sense? I'm not sure. Okay.
So, sir,
Sorry, go ahead.
So if it was cos 3 theta, it was going to be 3 cos 3 theta.
Yes.
Okay, thanks.
Chain rule. It's the chain rule. Remember, guys, when you have the chain rule, you take the derivative of the outside function multiplied by the derivative of the inside function. So the derivative of the outside function, which is sine, is just cos 4 theta, multiplied by the derivative of 4 theta in terms of theta, which is just 4, right? And then multiplied by d theta. Don't be alarmed by the theta. The theta could just be x. It could be x as well. So that should not scare you. Yeah. So any questions? Any other questions? If there are no questions, tell me what this integral is equal to.
E to the -3 divided by -3.
Okay. E to the -3 divided by -3 plus, well, plus c. Don't forget the constant of integration. So then this can be simplified to be -1/12u cubed plus c, which is just then equal to so putting back in the substitution that you used, this is just equal to 1/12 times 1 plus sine 4 theta cubed plus c. Not sure if this makes sense. So now that's it for that question. If you don't have any questions, we're done with this problem. Okay. So yeah. Next, you would look at this question here. And obviously for this question, you can try different use substitution, but since we're running out of time, I'll just give you a few suggestions on which substitution you should use, and then you guys can attempt it on your own. So, but first of all, before I give you my suggestions, what do you guys think we can use as a substitution for this problem?
Square root of x plus 1.
Square root of x plus 1. So if you let u be equal to 1 plus the square root of x, then you can solve for du and basically follow the same steps we've used before and see what happens and if you can get to the final answer. Okay. So yes, so that should be your homework. So finish up E.
Sir,
Yes.
sorry to step. What was the final answer of number C?
C. I don't have the final answer, but as I said, for integral questions, okay? So always keep this at the back of your mind, because I see a lot of people asking about, oh, what's the final answer of this? For these integration questions, it's very easy to know if you're wrong or if you're right. And the easiest way for you to know this is, like I said before, if you get your final answer, just derive it and see if you get the original question.
Okay, sir.
Yeah, take the derivative of whatever answer you get and see if you get the original question that is there.
Thanks, sir.
Yeah, no problem. Okay, so yeah, that is it. So you guys have to finish up E and C. And you can do 1 and 2 as sort of practice if you want, but it would be more practice for the exam. But yeah, that's it otherwise. Thank you so much.